In this video, we are going to study ARMA models in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Also, as you can see at the bottom of the screen, it is important to remember that when doing time series analysis and forecasting, past performance does not guarantee future results. Okay, so let's go into Spyder IDE. So the first step in the video is that we need to import the corresponding packages, therefore we comment this as step 1, which is packages. And we're going to import pandas as PD, we're importing pandas for data frames. Then we're going to import statsmodels.api as SM, we're importing that feature from statsmodels for data downloading. Then we're going to import statsmodels.tsa.statespace.sarimax as Sarima. We're importing that feature from statsmodels for the Arma model. And we are going to import matplotlib.pyplot as plt, and we're importing that feature from matplotlib for the corresponding chart. To run these code lines, we go ahead, select them, and then we can either click the Run Selection button or we can press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named mData, that's model data underscore obj or object, which is equal to sm feature from statsmodels.datasets.get underscore r dataset, and we open parentheses. First parameter, which is data name, equals to, within quotations we have air passengers, comma, and at the following row we have package, equals to, and within quotations datasets, comma, and at the following row we have cache, equals to true. So what we're doing here is the following. We're downloading air passengers data from our package datasets, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this downloads data and documentation within mData underscore obj object. Therefore, we're going to create a new object named mData with only the data, therefore equals to mData underscore obj, and we're going to get its .data attribute. And we're going to convert this into a pandas data frame. So we override mData, and it is equal to PD or pandas.data frame, and within it we have the parameter data, which is equal to mData, and we're going to select its value column, and we're going to set its index with .set underscore index and the parameter within parentheses at the following row, which is PD or pandas.date underscore range, and within it we have parameter start equals to, within quotations, 1949, comma, end equals to, within quotations, 1961, comma, FREQ or frequency equals to, and within quotations, M for monthly frequency. And then we want to visualize the documentation of this data, and we do so with print, and from mData underscore obj we're going to get its dot to underscores doc to underscores attribute. So to run this code lines, we go ahead, select them, and then we're going to press F9 on the keyboard. And as we can see, we have right here the documentation, so we scroll up and we have air passengers are documentation, and this is monthly airline passenger numbers in thousands from 1949 to 1960. And if we go into the variable explorer, we see the two objects being created within this variable explorer in Spyder. mData underscore obj with data and documentation, and mData with only the data as a data frame of length of 144 observations. So for this data, at any of these cells, if we double click on them, we can see the data, the index with the corresponding date, and the value here, which as mentioned previously, it's monthly airline passenger numbers in thousands. So now we're going to continue with ranges delimiting. And we are going to create two ranges, a training range for model fitting and a testing range for model forecasting. So let's begin with training range. We create the object name tData, which is equal to mData object, and we're going to select from the beginning of the time series all the way to the end of 1958, so 1958-12-31. So the training range is going to be the first 10 years of data from 1949 to 1958. That's why we see the end at December 31st of 1958. And then we're going to create the testing range, which is going to be fData, and that's going to be equal to mData object. And in this case, we're going to select from the beginning of 1959, so 1959-01-01, all the way to the end of the time series. So the testing range is going to be the last 2 years of data, 1959 on 1960. That's why we see the beginning at January 1st of 1959. So to run this code lines, we go ahead, select them, and we press F9 on the keyboard directly. And then we continue with step number 3, which is the ARIMA model. And for this, we're going to do model fitting within the training range and then model forecasting within the testing range. So we begin with model fitting, and we create the object name tModel, which is equal to, and here we'll be using ARIMA feature from statsModels.SARIMAX function, and within it the following parameters: endog with the data, in this case the training range data, so tData, comma, order equals to, and within parentheses 0, 1, 1. So this is an ARMA model with 0 autoregressive order, 1 order of differentiation or integration, and 1 moving average order. Comma, and at the following row we have trend equals to n. So here we are not including a trend component, and we go ahead and fit the corresponding model within the training range. Notice that range is delimiting, and this SARIMAX function parameters were only included as educational examples which can be modified according to your needs. So now we're going to continue with model forecasting. So we create the object name fModel, which is equal, and from tModel, the one we just fitted within the training range, we're going to use its forecast method, forecast, and within it we include steps equals to len of fData. So this is the number of steps ahead forecast, and that's the length of the testing range. Notice here that the forecast is done for the full testing range in advance without using any testing range data. And next we're going to convert this into a pandas data frame as well. So we overwrite fModel, and it is equal to, and here we'll be using PDR pandas.data frame, and within it we include fModel, and we're going to set its index with .set_index, and we'll use fData object, that's the testing range data, and we'll use its index. Okay, so to run this code lines, we go ahead, select them, and then we're going to press F9 on the keyboard. And the following step is we want to visualize this within its corresponding chart. So we do so with the following code lines, which are plt.plot, and first we're going to include tData, that's the training range data with its label, equals to tData. Then plt.plot, we are going to include this ARMA model forecast, so fModel with its label equals to fModel. And then we're going to include the actual data from the testing range, so plt.plot fData with its label, which is fData, and in this case with line style equals to, and within quotations, dash type of line style. And then we have plt.legend, that's going to be located with LOC equals to, and within quotations we have upper left. Then we have plt.title, and it's going to be within quotations ARIMA 0, 1, 1 model. Then we have plt.y label, that's the vertical axis label, that's going to be air passengers, and then we have plt.x label, that's the horizontal axis label, which is going to be year. And last we have plt.show so that we can visualize the chart. So to run these code lines, we go ahead, select them, and then we press F9 on the keyboard. And with this, we can see the chart right here within the console. And also if we go into the plots tab here within Spyder, we can see the chart with its title, which is ARIMA, with 0 autoregressive order, 1 order of differentiation or integration, and 1 moving average order. On the vertical axis, we have air passengers. On the horizontal one, we have year. And then we have the solid blue line, that's the training range data. Then we have the solid orange line, which is the ARMA model forecast. As mentioned previously, this was done for the full testing range in advance without using any testing range data. And then the dash green line, which is the actual data from the testing range. Okay. As mentioned at the beginning of this video, it is important to remember that when doing time series analysis and forecasting, past performance does not guarantee future results. Okay, so with this we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.